Hi everyone, and welcome back to my channel. Today we will continue talking about numbers. Make sure that you watch the last video about natural numbers and integers. Today we will talk about rational numbers. Sometimes we write it as Q. Now, rational numbers are the numbers that can be written as A over B, where A and B belongs to the set of integers, Z. Don't be scared from this definition. It's so simple. I'll give you some examples. The number 2 over 3, where 2 is the numerator and 3 is the denominator. It's considered to be a rational number. Why? Because 2 over 3 is the same as A over B, where A, which is represented by 2, belongs to Z. 2 is an integer. And B is represented by 3, and 3 is an integer. Another example. Minus 4 over 5. Minus 4 belongs to Z. 5 belongs to Z. So minus 4 over 5 is considered to be a rational number. 8 over minus 3 is considered to be a rational number. 8 belongs to Z and negative 3 belongs to Z as well. Now what about 0.3? 0.3 is considered to be a rational number. Why? Because any number with decimal point can be written as A over B. For example, 0.3 can be written as 3. Now, how many numbers after the decimal point? Only 3. Write it in the numerator and then divide by how many numbers again after the decimal point? Only one number, so we need only 1 0 and then add 1. Another example will make it easier. What about 0.54? Now the question is, how many numbers here do we have? We have only 2 numbers. Don't consider the 0. So we have 54. And then how many numbers after the decimal point? We have 2 numbers. Put 0, 0, and then put 1. So 0.3, we were able to write it as 3 over 10. And 0.54, we were able to write it as 54 over 100. So 0.3 and 0.54 are considered to be rational number. Another example. What if we have 1.5? Now, how many numbers do we have in total? We have 2 numbers. So write it as 15 without this decimal point, and then divide by how many numbers after the decimal point? Only one number, so add only 1 0 and then add the number 1. So 15 over 10 is exactly as 1.5. Last example here. Negative 6.34. How many numbers do we have? We have 3 numbers. Minus 6, 3, 4. Divided by how many numbers after the decimal point? We have only 2 numbers. So they are, put 2 zeros and put the number 1. So it's negative 634 over 100 is exactly the same as negative 6.34. Another example. What if we have 6? 6 is considered to be an integer. Is it a rational number or not? Yes, it is. Why? Because any number, any integer or natural number can be written as itself divided by 1. So 6 is considered to be a rational number. Minus 7. Is it a rational number? Yes, it is. Why? Because it's minus 7 over 1. Now the second set is the set of irrational numbers. Now we write it as I. So what are the irrational numbers? They are not rational numbers. What does that mean? It means that we can't write them as A over B, where A and B belongs to Z. We can't write them. For example, there's a special number called pi. Most people knows pi as 22 over 7 and sometimes 3.14. There are only approximate values for pi. Actually, pi is equal what? Is equal 3.141592653 and continue. It doesn't stop. Okay, so if we have this number, now we don't know how many numbers after the decimal point, so we cannot write it as as A over B. So the rule said any number that can be written as some digits after the decimal point, non-stop digits, and they are non-repeated, in this case considered to be an irrational number. Another example is Euler's number, E. I'll write it. Euler's number. Euler's number can be written as 2.71828, and it continues. It doesn't stop after the decimal point. So this one is another example for an irrational number. By the way, if you want me to explain pi and E in a separate video, please write me down in the comment box. Finally, the set of real numbers. R. Here, write it down again. R. Now, R actually is the set of rational numbers union the set of irrational numbers. So any number in this set, all numbers in this set, the set of rational numbers, and all numbers in the set of irrational numbers are considered to be real numbers. So any number like 2.3, -6, 21 over 5, square root of, oh sorry, I forgot to talk about square roots here in the set of irrational numbers. By the way, square root of 2 is considered to be irrational. Why? Because it is considered to be 1.4142135, and it continues. By the way, since it doesn't stop after the decimal point, it is considered to be irrational. Now, are all square roots or roots considered to be irrational? No. Let me give you an example. The square root of 4 is considered to be 2, which can be written as 2 over 1. So the square root of 4 is considered to be rational. Why? Because we were able to write it as A over B, 2 over 1. But the square root of 2 is 1.41242135, and it continues. So we were able to write it as A over B, so square root of 2 is considered to be an irrational number. So here, square root of 2 is a real number, and square root of 4 is a real number as well. Why? Because this one is irrational, and this one is rational. And we said that the set of real numbers is considered to be the union of rationals and irrationals. Thank you very much for watching.